Now we're going to learn something called the box method, and we use the box method when our polynomial has 3 terms and when our coefficient of the x squared term is 1. And when we use this method, just like with the grouping method, we will always take out the GCF first. That's important. We want to factor our polynomials completely, which part of factoring our polynomials completely is taking out a GCF if there is one. All right, so let's jump into that box method. So for number 1, out of all 3 terms, I don't have a greatest common factor, and my coefficient of r squared is 1, so that means that we're going to use the box method. What we do is we draw ourselves a box. Some of my students like to call this the T method as well because it looks more like a T than a box, but that's okay. And what we're going to do is we're going to split up our r squared evenly into an r and an r. I don't care where you put your r's. I like to put them diagonal from each other. If you put them, vertically from each other or horizontally from each other, it's okay. I don't care. But now what we do is we look at our last term, our constant. This is kind of like a puzzle, and some of you guys might like this concept because you're trying to solve a puzzle. We want 2 numbers when multiplied together equal positive 24, but when added together equal positive 11. So those are going to be the numbers 8 and 3. 8 times 3 equals positive 24, and an 8 plus a 3 equals a positive 11. So now, one of your binomials is an r plus 8. Your other binomial is an r plus 3. And again, it does not matter the order that these 2 binomials go in because multiplication is commutative. But you could check yourself to see if you factored correctly by foiling this back out and seeing if you wind up with your original polynomial. And in this case, we would. All right, number 2. I have 3 terms. None of them have a GCF. There is no GCF here. And my coefficient of y squared is 1, so we jump straight into that box method. We draw ourselves a box. My first term is y squared. I'm going to split that y squared up evenly into a y and a y, because a y times a y is a y squared. Now, I'm looking at my constant. I need 2 numbers when multiplied together equal a positive 8, but be careful on this one. When added together equal a negative 6. We should always include the operation that comes before our number. So that's actually going to be a negative 4 and a negative 2. A negative 4 times a negative 2 is a positive 8, and a negative 4 plus a negative 2 is a negative 6. So one of my binomials is a y minus 4. My other binomial is a y minus 2. All right, moving on to the next one. There is no GCF here. All 3 terms don't have anything in common, and the coefficient of my first term is 1, so we can jump straight into the box method. What I'm going to do is I'm going to split up my x squared evenly into an x and an x. Now I need 2 numbers when multiplied together equal a positive 2, but when added together equal a negative 1. Well, unfortunately, the only factors of 2 are 2 and 1, or negative 2 and negative 1 would give you a positive 2, but negative 2 plus a negative 1 does not equal a negative 1. So actually there are no 2 numbers when multiplied together equal a positive 2, but when added together equal a negative 1. And since we didn't factor out a GCF, there was nothing that we can do with this. What we're going to write is that this is not factorable. And sometimes you will get problems that are not factorable. All right, looking at number 4. There is no greatest common factor here. My coefficient of my first term is 1, and there's 3 terms, so this means I can jump straight into the box method. I'm going to take my first term of n squared and split it up evenly. I need two numbers when multiplied together equal a negative 36, but when added together equal a positive 9. That's going to be a 12 times a negative 3 is equal to a negative 36, but a 12 plus a negative 3 is a positive 9. So one of my binomials is an n plus 12. My other binomial is an n minus 3. And it does not matter what order you write these binomials in. All right, looking at number 5. There is no GCF. My coefficient of my first term is 1, and since there's 3 terms, we're going to use the box method. So I'm going to split my c squared up evenly into a c and a c. I need two numbers when multiplied together equal a negative 21, but when added together equal a negative 4. That's going to be a negative 7 times a 3 is a negative 21, and a negative 7 plus a 3 is a negative 4. So one of my binomials is a c minus 7. My other binomial is a c plus 3. All right. Now in number 6, all 3 terms actually have a w in common. So we're going to factor out that greatest common factor of a w. And now I have a w squared plus a 4w minus a 32. So what we're going to do is we're going to use what's on the inside of parentheses, and this is a trinomial on the inside of parentheses with a coefficient of my w squared being 1. So I'm going to use my box method here. I'm going to split up my w squared evenly into a w and a w. Now I need two numbers when multiplied together equal a negative 32, but when added together equal a positive 4. That's going to be an 8 times a negative 4 is equal to a negative 32, but an 8 plus a negative 4 is equal to a positive 4. Now we need to write our GCF first, which was w. Don't forget that GCF. Then we write one of our binomials, which I'm going to write a w plus an 8. And then we write our other binomial, which is a w minus a 4. That is fully factored now. All right. Looking at number 7, this is a little slightly different. There is no greatest common factor on number 7. However, when we jump into the box method here, what we're going to do is we're going to split up our m squared evenly. And since my last term has an n squared in it, we're going to split that up evenly in my other two boxes. And now we're going to get started with the numbers. So I need two numbers when multiplied together equal a negative 27, but when added together equal a positive 6. That's going to be a 9 and a negative 3. We attach those to the n's, not the m's. So one of your binomials is going to be an m plus a 9n. And your other binomial is going to be an m minus a 3n. So same type of thing in number 8. When we jump straight into that box method, because there is no GCF, I'm going to split up my a's evenly. And then since my last term does have a b squared on it, I'm going to split that up evenly in the other two boxes. Now I need two numbers when multiplied together equal 32, but when added together equal 12. That's going to be a 4 and an 8. And those get attached to my b's because my b squared was in my last term. So one of my binomials is an a plus a 4b. My other binomial is an a plus an 8b. All right, number 9. We do have a greatest common factor here. I'm going to factor out a 4. When I factor out a 4, I'm left with an x cubed plus a 4x minus a 5. Unfortunately, even though what's left on the inside is a trinomial, your first term is an x cubed, not an x squared. Now, we can factor trinomials when our first term has an even exponent, but when our first term has an odd exponent, like it does here, we actually can't factor this any further. But we're not going to write not factorable because we did do something from the original problem. We did factor out a 4. So we did factor something out. So it's not factorable. This is just your answer. You leave it like that. All right, number 10. Remember what I said on number 9, how if your first term has an even exponent, then you can use the box method. So we can use the box method here. Splitting an r to the 6th power up evenly, 6 divided by 2 is 3. So I'm going to split it up into an r cubed and an r cubed. Now I need two numbers when multiplied together equal 80, positive 80, but when added together equal negative 21. So that's going to be a negative 16 and a negative 5. So one of my binomials is an r cubed minus 16. My other binomial is an r cubed minus a 5. Okay, number 11 is a little tricky because if you recall, up above in the directions, I said that your coefficient of the x squared term needs to be 1. Well, in number 11, my coefficient of my x squared term is negative 1, and I need to get it to positive 1. So what I need to do here first is I need to factor out a negative 1. I don't divide by negative 1 because this is an expression. I cannot divide an expression by a number. So what I do instead is I factor it out, and it's just as good as doing division here. I have a positive x squared now, minus a 3x, minus a 4. So my greatest common factor was negative 1. And now on the three terms that are left in parentheses, now I can do the box method on them. So I'm going to split up my x squared evenly. I need two numbers when multiplied together equal a negative 4, but when added together equal a negative 3. Well, that's going to be a negative 4 and a 1. So I first write my greatest common factor, which is a negative 1. Then I write my binomials, which my first binomial is an x minus a 4, and my next binomial is an x plus 1. Again, the order that your binomials goes in does not matter. All right, and then the next one, my greatest common factor, because I do have one here and I need to factor it out first, is a 3. I'm left with an r squared plus a 19 rs plus a 90s squared. What's left on the inside of my parentheses is a trinomial that I can use the box method on. I split up my r squared evenly into an r and an r. Since my last term has a variable squared in it, I split that up evenly into an s and an s. Now I need two numbers when multiplied together equal 90, but when added together equal 19. Well, that's going to be a 10 and a 9. And those get attached to my s. I cannot forget that I took out a GCF out of the beginning, so that needs to go on to my answer first. Then I write one of my binomials, which I'm going to write my r plus 10s first. And then I write my other binomial, which is an r plus 9s. And that is fully factored. Remember, you cannot leave out your greatest common factor. That is part of your answer as well. All right, that brings us to the end of the level 2. You're going to now do your practice.